Hello everyone, welcome to Java Tutorials. My name is Kishore. In this video, we will discuss about collection framework. What exactly collection framework does is it allows you to maintain group of elements in a container where you can store elements of same types or multiple types. We have arrays to maintain the data, but why we should go for collection framework means in arrays you should only write the algorithms for different kind of requirements. Sometimes you have a requirement to store the elements in sequential order. Sometimes you will have a requirement to store the elements in random order. Sometimes you will have a requirement to store only unique elements. Sometimes you will have the elements to maintain in sorted order, and sometimes you want to maintain the elements so that you need to remove the elements to process in first out order, or in last in first out order, or in sorted order you want to remove the elements. All these algorithms you need to write. And also array size is fixed. Once it is created you cannot change its size. So these are certain drawbacks with arrays. For that reason we have collection framework which can maintain different types of data, and its size is not fixed because collection framework is developed by Java and it is dynamic in nature. When you add the element, the collection would grow. When you remove the element, the collection size would shrink. It provides various methods to maintain the element, and all those methods are declared in one of the top interface called collection. Those methods are add, remove, iterated, size, clear, isEmpty. There are few other methods in collection interface, but we are going to discuss these methods because they are going to be used in lot of places, and it is like more widely used methods. Add method, as the name itself suggests, it is to add the element. If you want to remove the element, there is a remove method. If you want to iterate over the collection, there is a iterator. If you want to read the size of the collection, there is a size method. You want to remove all the elements, there is a clear method. You want to find collection is empty, then there is a isEmpty method. All these methods are abstract because collection doesn't know how the elements should be maintained or how the elements should be removed. For that reason, all these methods are declared in collection. Then we have list, queue, set. So what are these list, queue, and set? If you ask, list, set, queue, all these are the interfaces which extends collection, because you may need to maintain the data in various format. There are three subdivision in collection which are again interfaces. List actually maintain the elements in index based so that you can always add the element, remove the element, or get the element based on index. And the list supports duplicates as well. You can store duplicate elements in the list. Then what about queue? Queue is mainly you want to process the element after removing. Like once the element is maintained, you want to remove that element for further processing. Then you should use queue. Like you want to remove the element in first out order, or you want to remove the element in sorted order. Then queue is going to be useful. What about set? Set is an interface that is going to tell the implementations that it has to maintain the elements only unique element should be maintained. Means no duplicates are allowed in case of set. That is why there are three subtypes based on the requirement. Then there are multiple implementations. You can observe the dotted lines means they all are implementations, and the continuous lines means they are extensions. List, queue, set extends collection. Array list, linked list, priority queue, hash set, linked hash set, and tree set are all classes. Array list and linked list implements list. Linked list also implements queue, thereby it acts like first in first out also. Priority queue also implements queue. Hash set implements set, and linked hash set is a class that extends hash set. Then tree set is implementing navigable set, sort and sorted set and set. So that tree set can actually allow you to sort the element, and also it allows you to navigate while sorting. And you can observe here, there are totally how many classes we have mentioned: array list, linked list, priority queue, linked hash set, tree set. So totally 3 plus 3, 6 classes. But are only 6 classes available in collection framework? If you ask me a question, the answer is no. There are a lot of other implementation classes also available. They all have these common methods. That is what you should understand. Now coming to list, what it does, it allows only duplicate elements. It means array list and linked list should support duplicates, and both should support index based maintaining the element, like adding, removing, and reading the elements. And what about priority queue? Priority queue is mainly used in order to remove the elements based on priority. So what is the priority? By default, it is going to remove the element in sorted order. And if you want to actually give a priority, like in it has to remove the elements in different sorting order, like descending order, because the by default the priority queue sorts the elements in ascending order while removing. And in case you want to sort and remove the elements in descending order, then you can change the implementation of priority queue by passing some objects like comparator implementation objects and all. And what about array list? Array list is going to maintain the elements in contiguous memory address, means all the elements will be stored in contiguous order. So what happens in case of array list? If you store some elements, let's say I have some elements like 3, 4, 6, 5, 1, 2. Then what array list does is it is going to store all these elements in contiguous memory address like 3, 4, 6, like this. But what happens in case of array list, if you try to remove or add the elements in between, then all these elements will be shifted to different memory address. It means it will be copied. So the 3 will be copied to the next memory, or you can say to a new memory, and 4 will be copied to the new memory. And in between 4 and 6, say for example, in between 4 and 6, you want to add 8. Then 8 will be copied first, and then 6 will be copied. This way, it is going to maintain that continuity. So array list maintains the element in contiguous order so that retrieval will be always faster. The reason is the elements will be like whenever it has to read the next element, what happens is immediately the next element it can find in the next address. For that reason, the retrieval will be faster in case of array list. What about the adding and removing? Because when you add or remove the elements, see for example, I want to remove the element, again what happens in array list is it is going to again create a new memory of array list, and then everything will be again copied to the new memory without that element you want to remove. Means 3 is copied, then 4, then 8 won't be copied, then 6, and the remaining elements after 6 will be copied. So the array list adding and removing will be slower, but retrieval will be faster. So then you might ask here, then what is the use of array list? Adding and removing is slow, we don't need to use array list then. You need to understand, based on the scenarios, you should go for different classes. The first class which I am explaining is array list. You should use whenever the requirement is like this, where you do rarely adding and removing of the elements in between, but frequent retrieval you will do. In such cases, you can go for array list. Say for example, you are developing a system for university, and in university the professors every hour they use the application to retrieve the student details. Every hour they are doing the read operation to mark the attendance, and they don't add or remove the elements in every hour. So adding and removing of the elements might happen once in 6 months or once in a year, whenever a new student joins or whenever the student should be removed from the college. So this system should use array list because adding and removing is rare, but retrieval is happening every hour. So you need to choose array list in such case. Next, what about the linked list? Linked list also supports index-based maintaining element, but the way it adds the elements and iterates is going to be little bit different when it compares when we compare with the array list. How the linked list stores the element is, suppose this is the order you are storing the element, then linked list is going to create a link between each element. That is going to be the doubly linked list. The first element will have a link with the second element, and the second element will have a link with the third element, and as well as the first element. The third element will have a link from between the second element and the next element, that is 4. So it is going to have a doubly linked list so that you can traverse in reverse order also, even you can traverse in forward direction also. That is one thing. But it won't be in contiguous memory address. Whichever the memory is free, that memory is going to be occupied whenever you add the element. And how does the adding and removing works is, in case you want to remove the element 5, then only the link between the 5 will be broken, and it is going to create a new link between the element, previous element, that is 7, and the next element 4. Similarly, when you add an element, say for example, when you add some new element, let's say you're adding some element called 20, then what happens between 3 and 7, if you are adding, then the old link between 3 and 7 will be deleted, and a new link from 3 to 20 and 20 to 7 will be created. Thereby it doesn't change the address of the elements, it only it is going to only remove the element or create the remove the link, or it is going to create the links. So performance wise, adding and removing is much faster in linked list comparing with the array list. But when it comes to retrieval, it has to travel from one address to another address. It is going to be little bit slower, not that too slower. It will be slower compared to array list. So you choose a linked list whenever a frequent adding and deleting happens, and rarely the retrieval happens. Like frequent means like out of 10 times, you might read the element 2 or 3 times. In such scenarios, you go for linked list. In lot of adding and removing uh, cases could be like adding the elements in the shopping cart applications, where customers keeps adding the elements, removing the elements, and retrieval should happen once they go to the checkout. It has to retrieve each and every element to calculate the total price and apply the tax. So retrieval should happen. It's not that retrieval rarely happens. It should happen, but every time you add and remove the elements, uh, the performance should be faster. For that reason, linked list would be better in such scenarios. But you can notice that linked list also implements queue, because linked list can also perform the operations like first in first out operation. Queue provides some extra methods to do that first in first out. And please remember, these operations are inbuilt. You do not need to write any program for adding and removing or reading. They all are already available. You just need to know how these classes work. Coming to the next one, priority queue, which is an implementation to the queue. How the priority queue is going to work is, it is going to remove the element in sorted order. By default, it sorts in ascending order, but you can always pass some parameters to the priority queue so that you can also sort the elements in descending order. So like in sorting order, if there are some elements, let's say some elements like 4, 5, 6, 9, 8, something like this. Then there is an element like 20. If this is the way the element is stored in priority queue, the first element that will be removed is 4, because that is the correct sorting order. And you might ask, like, in which scenario we should go for priority queue. Now, if in case I want to use priority queue for these elements, first element that will be removed is 4, the next would be 5, the next would be 6, the next one would be 8, and then 9, then 20. And even in descending order, if you want to remove, the priority queue is going to take some parameters, right? So it means it will be removed from 20 to 4. So consider a kind of a bidding application. In bidding application, priority should be given based on the price. The highest price whoever bids, for them the order should be processed. In such case, if there are these orders, then what if 20 should be processed first? Then obviously you can always maintain those orders, and then you can process it by using the priority queue, by using the method to remove the element. Um so that is how the priority queue works. You use the priority queue in such scenarios where you have a requirement of processing the elements based on some priority. Next comes the set. How the set works is set allows you to maintain only the unique elements, means it never allows duplicate. And there are totally three implementations: hash set, linked hash set, and one more is tree set. And wherever the C is written, they all are classes. Wherever I is written, they all are interfaces. So how does the hash set work is, hash set doesn't maintain the order, but it uses an hash based maintaining element or searching element so that retrieval will be faster. Suppose I store the element like this: 8, 9, 7, 6, 5, 4. Then based on the hash implementation, the hash set stores the elements in some random order. But retrieval will be faster because the hash set uses some key to read the element. For that reason, hash set is used. It is mainly used whenever you want faster retrieval, then you can go for hash set. But I am not explaining what is this key, how exactly the hash set works in this video. The reason is I am going to take a separate example to explain hash set, because I need to discuss few methods like hash code and equals while explaining the hash set implementation. But right now, what you can think of as that is, it maintains only unique elements and order is not maintained, but retrieval will be faster because it uses hash algorithm. Then comes the linked hash set. It maintains the elements in insertion order, means in what order you have added, the same order it maintains. Then comes the tree set. Tree set maintains the elements in sorted order. It means if these are the elements you are trying to add in the tree set, then they will be added like this. That is how the tree set maintains the elements, and none of the implementation is going to allow duplicates. So currently I am using numbers, but in real time you do not use numbers to maintain the elements. You maintain customer objects, you maintain employee objects, you maintain product objects, like that different types of complex objects you maintain. To understand the collection in a simple way, I used numbers, but we are going to discuss collections with numbers, strings, as well as complex data types also. So we will discuss the practical part in the next video. This is just to understand how these classes work. Thank you so much. See you in the next video.